This video is going to explain how to solve quadratics by graphing by using your graphing calculator. I'm going to explain the steps and then I'm going to show a couple of examples using a graphing calculator. Our answers are going to be rounded or approximated solutions. So whenever you have solutions that are not whole numbers or integers, what you want to do is round to the nearest hundredth. Round to the nearest hundredth. So that's going to be 2 decimal places. The first step we're going to do is we're going to plug the equation into y1. So we're going to put it in standard form. We're going to plug that equation into y1, and then we're going to make the y2 equal to 0. Now there's another way we can look at this as well, and I'll show you both ways. Our second step, we're going to press zoom 6 so that we can see a standard graph. However, if your graph is not crossing between -10 and 10, you might need to zoom out if you can't see the graph. I'm going to make a note here. Might need to zoom out if you can't see the graph. And I'll explain how to do that as well. The next step is once you have your graph in your screen, you're going to press second trace 5, which is actually where you're going to find the intersect. Once you've done that, what's going to happen is when you press zoom 6, you'll see the graph, and then you'll press second trace 5, which will take you to another screen. But as soon as you press the 5 or enter on the intersect, it'll go back to the graph, and you'll end up seeing a cursor blinking. So what you're going to do is you're going to move the cursor. You're going to press either left or right to make it go to one of the x-intercepts. Again, it's where it's crossing the x-axis. So we only want to go to one at the moment. Once we get close to it, so as long as you get as close as possible, because sometimes it won't be possible to actually get on the x-intercept because the cursor just won't let you. But as long as you're near that x-intercept where you want to be, you can go to the next step, where it's just press enter 3 times. So just press enter, enter, enter. It'll end up saying first curve, second curve, intersect. You don't want to stop until you see intersect. So when you've done this, when you finish that part, it will give, so your calculator will give an x-intercept. And it'll give you an x equals and a y equals, and your x-intercept will be your x value, comma, 0. Now if your y value ends up being some weird number, it'll say a number, and then it'll say e negative 10. That really means 0 because your scientific notation, what you're doing is moving your decimal place 10 spots to the left, so then it'll round to 0. And then the last step is when you have figured out this x-intercept, if you have more x-intercepts, which you should, you just repeat steps 3 through 5 for the other x-intercepts. You don't have to go back and graph the equation or plug it in or press zoom 6. You just have to go back and press second trace 5 again and then do the steps again, just to the other x-intercept. So what I'm going to do is I'm not going to write any examples down. I'm just going to show you a couple of examples of how to put them in your calculator and what it'll look like. So I turn my calculator on. I am using a color calculator so you can see the different things I'm going to use for my equations. So I'm going to go to my y equals. I'm going to plug in my first equation. It'll already be in standard form. It'll be x squared minus 8x and then plus 15. And then it's equal to 0, so I'm going to go down to the y2 and set it equal to 0. Now I'm going to press zoom 6. Because 6 says it's standard, Z standard. It's going to go to the left 10, right 10, up 10, and down 10. It'll just be your normal scale. So we have the scale. It's going to graph my parabola. Now as you can see, it crosses the x-axis twice, so I'll have 2. And then I'm not sure if you noticed that, but the graph also went here. That was my y equals 0. That's why we want to put y equals 0, and I'm using a color graph because mine's actually going to be red right there. I know you probably can't see that, but I can see my 2 x-intercepts right there. So I'm going to press second trace button right here. I'm going to do number 5. When I press 5, it'll go back to the graph. And now I don't see my cursor yet, but you see how it says at 0, 15? That's actually where my cursor's at. So here's 0 and 15 is way up here. I know I have to come down to here, so I'm going to press the right arrow key to make it come to the right. And you can see the numbers are changing, and as it changes, the cursor it moves. So I'm going to get as close to this x-intercept as possible, and I actually I'm fairly close to it. So I'm going to press enter 3 times. So it's already at first curve. So enter, second curve, enter, turns into guess. I don't want to guess, so I'm going to press enter until I get to intersection. It says intersection. My first intersection is at 3, 0. So that's my first solution, is x equals 3. So I'm going to go back and do second trace 5 again, because I found that first one. So second trace 5. Now my cursor is back where it started. I need to find the other one, so I'm going to go to the right until I get close to that x-intercept. As long as I'm close to it, I should be good. And it's actually there, but I want to make sure I press enter 3 times still. So enter, enter, enter. Inside intersection, we have 5, 0. So I had 3, 0 and 5, 0. Those were real and rational, so that means that my equation, that x squared minus 8x plus 15, could actually factor. So I could have factored that to solve instead of using my calculator. Now I'm going to show you another one. So I'm going to clear this out. I'm going to have 8x squared minus 2x and then minus 5. I'm going to keep my second one equal to 0 so that I can find the x-intercepts. So I'm going to press graph. So the first one's going to be the parabola. And then as you see, it's going to come. It makes a line. It's going to the right. That was my y equals 0. I pressed graph because I'd already pressed zoom 6. I was still in the standard window. So now I can do the second trace 5. My cursor is blinking here because that's the y-intercept. That's where your graph actually starts at all the time. It starts with the y-intercept. So I'm going to go left to find this one on the left-hand side. And you see how I can't actually get onto the x-intercept? But as long as I'm close to it, I'm okay. So this is actually pretty close to it. So I press enter 3 times. 1, 2, 3. So my y is equal to 0, but my x-intersection is a decimal value. So I'm going to say this is at negative. And it's 0.675, but that 5 will make the 7 go to an 8. So the way we say that is actually at negative 68 hundredths. Negative 68 hundredths. Because this is into the nearest hundredth, and you don't want to just say negative 0.68, because that doesn't really mean anything. So negative 68 hundredths tells me what the decimal value is. So now I will write that down, and then I'm going to go to find the other one. So I'm going to go back to second trace. I'm going to number 5 again. Now I'm going to go to the right to that other intersection, and that's pretty close to the intersection. So I'm going to press enter 3 times. So enter, enter, enter. And now this is that, so we have that 9, 2, 5. So again, that 5 makes that 2 go up to a 3. So we have 93 hundredths. So our x value is at 93 hundredths. Now actually, I want to take this equation again. I'm going to show you another way of looking at this. The original equation said 8x squared minus 2x equals a positive 5. So if it's equal to a positive 5, that's why I got the negative 5 to put it back in the standard form. But I can actually, and I can do this with any graph, I can have 8x squared minus 2x. But then since it said equal to 5, I can actually go down to my y2 and say I want it to equal to 5. This is the same thing as a system of equations where I want to find the answers. So again, I've already pressed zoom 6, but what I did was instead of putting it in standard form, I just kept this was the left side of my graph, or my equation. This was the right side of the equation. So I'm just going to press graph. I'm still going to have a parabola, but it won't look the same. And I'll still have a horizontal line, but it's also not going to look the same. But these are still the same information. When I get my values, it should still be the same answers. I'm going to press second trace 5, but this time I'm not going to the x-intercept, I'm going to where they cross because I want the intersection. So I go left until I get up close to here. So I press enter, enter, enter. I get that negative 68 hundredths again. So I do second trace 5 and go to the right. I press enter, enter, enter. I get that 93 hundredths as well. It's just that this time my y is 5 because that was my second equation, y equals 5. I ended up getting the same answers for my x, and that's what matters. The only difference was, instead of me putting it back into standard form, I kept my left side of my equation in y1 and my right side of the equation in y2. And you can do that if you're using your calculator. Otherwise, if you're going to try and solve it any other way, it needs to be in standard form and set equal to 0. The zooming option, I also want to talk about that. So if I want to go back to, I want to put this back to 0, and I'm going to put this back to -5. Let me see my graph again. This is what my original graph was. We have that second line. Okay. Now I just want to explain how to zoom on here in case you do need to zoom out. Now in this case you can obviously see your graph and you can see your intersections. But I'm going to show you zoom. And I'm going to go down to zoom 3. I'm going to press just enter on 3. Now the thing is that the graph hasn't actually changed. Because what it is that you actually have to tell the graph where you want it to zoom out from. So you can actually move your cursor. And if I just zoom out from the center, so I'm just going to press, I have to press enter for it to zoom out. So I'm going to press zoom out now. Enter. Now it's going to zoom out. Now the graph looks different. But if I want to go back and I'm going to go back to standard real quick so I can show you another one. So here comes the graphs again. Back to the original. So I'm going to press zoom. I'm going to go down to 3 again. But again, my graph hasn't changed. Let's say our graph is way over here and I need to zoom it out from here because this is a location I need. I can actually move my cursor over to the side and tell it I want to zoom out from this side. So now this side will be more zoomed out. So I have to press enter now. Now as you can see, the graph has actually shifted to the left so I can see more of this section because I wanted to zoom out from this section. So when you're zooming out or in, you can actually tell it where to zoom out or in from by just moving your cursor and then pressing zoom out. If I wanted to zoom in, I'll do 2, and then I have to press enter on here. And so it actually zoomed in on that location. If you wanted to go back to the 10 by 10, zoom 6 is how you go back to the 10 by 10. As you can see, that's 10 by 10. Now if I press enter, mine keeps loading. That's if yours never stops loading, it's because you press enter too many times. So if I press enter again, it turns a different color and then it loads back. When it's done, it stopped loading. And that's how you can solve quadratics by using your calculator. Again, if you put in standard form, put that into y1, and then your y2 just put equal to 0, and find the solution by finding where it crosses the x-axis.